Given the standard normal, we want to find the probability that z is between minus 0.8 and 1. If you are supplied with two-sided tables, this really is a straightforward example for you to do. You can simply do phi of 1 take away phi of minus 0.8 and read off the answer. You could have done the last example in a similar way, using phi of 0.5 take away phi of minus 0.5. However, most examples supply with one-sided tables, so the following approach will be needed. Remember that one-sided tables are tables which start at z equals 0, and to work with negative values for z, values to the left of the mean, you need to use the symmetry of the curve. Let's use a sketch to identify the area that we want. So we'll sketch the standard normal. Remember, the mean here is at 0. If we have 1 here and minus 0.8 here, the area we want is this area, and it's not a symmetric area, so we can't use the sort of trick we used in the last example. However, we can see that the area is made up from two areas. One of the areas is the area from 1 down to the mean, and the other area is the area from the mean down to minus 0.8. Because the curve is symmetric, this will be the same as the area from 0.8 down to the mean. This area here is going to be phi of 1 take away 0.5. Remember, phi of 1 gives us the area all the way from 1 down to minus infinity. The area to the left of the mean is 0.5 because of the symmetry of the curve. So if we do this subtraction, we get the shaded area as shown. We do the same here, and this must be phi of 0.8 take away 0.5. This gives us phi of 1 plus phi of 0.8 take away 1. So looking up tables, we get 0.8413 plus 0.7881 take away 1, and this calculates to 0.6294.